Hello, everyone. This is the final exam review for Math 1324. We have 50 questions we're going to go through. We will do this in sets of 10 questions each. So we're going to start working on the first set, questions 1 through 10. So the first question we see is we're looking for the domain of the function. Now let me write down the function. F of x equals the square root of negative x plus 13. Okay, now we have a radical function. And in order to find the domain of a radical function, radical functions have restricted domains. So we have to write an inequality and solve an inequality. So we take what's inside the square root for this radical function. So we have negative x, and we solve the following inequality, greater than or equal to 0. So whatever's inside the square root, we write, and we solve greater than or equal to 0 for whatever expression we have inside the square root. Now, in order to solve this inequality, we either multiply by -1 or divide by -1 because you're looking for x, not negative x. So I'm going to divide both sides of the inequality by -1. Now, what that's going to do to the inequality sign is going to reverse it, right? So it's going to change to less than or equal to. So we have x is less than or equal to 0 divided by -1. That's going to give us 0. So as we see that x has to be less than or equal to 0 for this function to be defined, for the domain to be defined. So the domain is any x less than or equal to 0. So if you were to graph this on the number line, you have 0, and then we put a bracket at 0, meaning, you are including 0, and then anything less than or equal to 0, it's included in the domain. So it's all the shaded area there. And the way you will write that using interval notation would be just follow the graph. It would be from -infinity, and we put a parentheses around -infinity all the way to 0, and a bracket. The bracket implies that you are including 0. So any number from 0 and less than 0, so 0 or less than 0, will be included in the domain of this function. Okay, so this is a radical function. Okay, so that's the domain. Now let's move on to the next question. And we're looking for the domain of the following function. And as we see that that is a rational function because it has x in the denominator, right? And so let me write that down. So we have x plus 6, and then we have in the denominator, we have x squared minus 9. Okay, now, as you remember, the denominator cannot be 0, right? Because that's an undefined concept. So how do you avoid 0 in the denominator? So you look at the denominator, and we just pay attention to the denominator. So here's the denominator, x squared minus 49. And observe, we can solve this by inspection. So when you think of x squared minus 49, you have to find the value of x or values of x that will make the denominator equal to 0. And there are only two values of x that will do so. And that's going to be -7, because you can see that -7, when you plug in, if x is equal to -7, then x squared is equal to -7 times -7, which is equal to 49. And 49 minus 49 is equal to 0. So the same thing you can say about if x is equal to 7, right? Then x squared is equal to 7 times 7, which is 49, and we have the same problem, right? So if I draw the number line, I will know that -7 and 7 cannot be included, and so I can draw an open circle. This is another way you can you can refer to whenever you're trying to omit a number from the domain or from the range, you can draw open circles on the number line. And so now think of this as the X. You're just looking at the X values that are allowed here. So we have everything except those two numbers can be included as part of the domain or are included as part of the domain. So you can see the shaded area there. So that would be, let me make sure that you can see everything there moving. Sorry about, I was not including this part. So how would you write the domain? We read this from left to right, from left to right. So the domain, you can write it in interval notation. And this is usually how they want you to write it in interval notation. So you write it as negative infinity to -7, right? And then you can say, or you can put the union symbol there, depends on whether they would accept that or not. But it's or, and then this interval here from -7 to 7, or from 7 to infinity, because any x in these intervals will be included as part of the domain, right? And so that would be the answer to number 2. Okay, so that's number 2. All right, let's move on to number 3. And number 3 is this is a function, and we call that a piecewise defined function because it's defined differently from different parts of the domain, right? So the domain is stated here on the right side, right here, the values of x. And for each value of x presented here, you have a different expression for the function. So this is called a piecewise defined function. So if we have 3 different pieces, we can think of it like that, defined for, and it's defined differently for each expression. And so now, what are we asked to do here? Let's read. A state's income tax for a single person in a recent year was determined by the rule below, where X is the person's taxable income. Okay. So if a person is making, so let's understand what this is saying. If a person is making from 0 to 6,000, and this is per year, we use the first expression. And then if a person is making anywhere, so first expression is from 0 to 6,000 to just below 6,000. So anything below from 0 to 6,000, but not including 6,000, right? So 6,000 is not included, is the first expression. The second expression is from 6,000 to less than 12,000. And then the third expression is for anything greater than or equal to 12,000. And then we need to find the function values and interpret the answers. So we have to interpret the answers as well. So we'll go through, I can do maybe the first one, and because they repeat themselves, so I'll show you how to do A, and then you can do B and C the same way, right? It's the same process. So I will show you for the sake of time, because I don't want to make these videos too long. So I will show you how to do this part A, and because part B and part C are exactly the same, I'll just give you hints as to what to do on the other 2 cases, okay? So let me write down the function first. So number 3, we have h of x equals 0.02 x if we have an income between 0 to less than 6,000. And then we have 120 plus 0.03 parentheses x minus 6,000 if we have 6,000 less than or equal to x less than 12,000. And then we have 300 plus 0.04 x minus 12,000 for x greater than or equal to 12,000. And so I will do B. I will show you how to do B. And then you guys can, because if I do A is a little bit too easy. So that's just a plug-in, for or 3,570. So basically, that's all you're doing here. You're going to plug in, for example, for A, age of 3,570, a person is making $3,570 or made that much in a year. So you're gonna use, where is 3,570? It's the first part, right? It's the first expression. 3,570 is between 0 and 6,000, less than 6,000. So you would just plug in the 3,570 into the first expression, right? And since I'm doing B, so I'm going to do B. Let me write down B. So if a person made 9,000, so we're looking for person who made 9,410. This was the income. So how would you answer that question? So what you're going to do, let me stop sharing here so I can show you. A person who made this much, 9,410, that's the income. And so where is 9,410 is between 6,000 and 12,000, right? So you'll plug it into the second expression. So you will write something like h of, because that's the function, the x is the income, 9,410, and that gives me, so you write 120 plus 0.03, the x is 9,410, and then minus 6,000. And then you use your calculator to calculate the tax, right, for that. And so using your calculator, you can enter 120 plus 0.03 parentheses, 9,410 minus 6,000, and then close the parentheses. And the tax that this person's going to pay is 222. And you see how it's just 0.3, so you have 30 cents. So $222.30, right? And similarly, you do parts A and C. So A and C are done in a similar manner, or are solved in a similar manner, okay? But like I said, because we want to save time, we don't want to do the same question, repeat the same question. So that is basically, so when you look at the solutions for B, you can read here, for example, an individual with a taxable income of, you're going to enter here, 9,410 will have to pay $222.30 as tax. So for the part I did, I will select this B. I will fill in the amounts here for the income and for the tax. Okay, you'll do the same for A, C, and D. For the other parts, I believe it's only, I don't know why it says D here, because it's only 3 parts, I believe. Yeah, it's only A, B, and C. Okay. All right. So now let's move on to question number 4. And this is a graphing question. So it's a piecewise defined function, but now we're going to graph it. Okay, so let's go ahead and write. So the question number 3 was basically read the piecewise defined function, read the information, understand it, and then just plug in and plug in the income level into the right expression, and then find the tax amount at the end, right? So it had 2 parts. For this, we actually have to graph in order to select the right graph. So how do we graph a piecewise defined function? Well, first of all, we look at the piecewise defined function and we understand what it's saying. So f of x is equal to -3 minus x if x is less than or equal to 2. And f of x is equal to -6 plus 2x if x is greater than 2. So 2 is going to be the target of where we're going to have some sort of change in the shape of the graph, right? So we can plot some points, and 2 points is enough to get an idea of the graph, as long as the points are distinct, number one. Of course, they have to be distinct. And then separated with enough, space to see the change in the graph, right? So let's go there to the, let's go ahead and write down the function, and then we can take a look at how we're gonna graph it. So we've got -3 minus x, and then -6 plus 2x, and then it says if x is less than or equal to 2, and then this says if x is greater than 2. All right. Okay, now let me go ahead and stop sharing here. Okay, now, so we have two cases, x less than or equal to 2 or x greater than 2. So we're going to talk about the first case, less than or equal to 2, because we have x equals 2 in the first expression. We can say, okay, I know I'm going to have add to a closed circle, and you'll understand what I'm talking about here. So I'm just going to write a closed circle here because of the equals. And then I'm going to create a little table here of values, right? And then I'm going to work with the first expression because x can actually be equal to 2 in the first case. So I can start with -2. And remember, you're not restricted by the x values because the domain is all real numbers, but um, it's broken into two parts. Even though it's all real numbers, you can see it's all real numbers because it's x less than or equal to 2 and then greater than 2. So it's basically every real number, but you have to consider the cases. So case 1, the equal sign gives me this closed circle at 2. So this is going to be +2, not -2. So +2 there. And now less than or equal to 2. So I'm going to start at 2, but then I have to remember that I have to be at less than or equal to 2. So I can do maybe 1 here. So 2, 1, 0, and then -1. That's, that's enough, I think, for us. And so to get the y value, what the y is, the first expression is -3 minus x. And so you're going to plug in, right? You're going to plug in the values for x. So y is equal to -3 minus 2. So that gives us a -5, right? For the first value of x. And then you do the same for the second. So y equals -3 minus 1. So that's a -4. And then y equals -3 minus 0. That's a -3. And then y equals -3 minus -1. That's going to be -3 plus 1. So that's a -2. And so we have enough points there for the first case. Second case, I'm going to consider the open circle at this, and I'm still going to start at 2 for the x, right? I'm still going to start at 2. But now I have the open circle, and the expression I'm going to use is -6 plus 2x. And so here you can say, well, I'm going to start at 2, and then you can say, well, 3, 4, 5, just to make it simple. So y equals -6 plus 2 times 2. So that's going to be -6 plus 4. That's a -2. And so y equals -6 plus 2 times 3. So that's -6 plus 6. That's 0. And y equals -6 plus 2 times 4. So that's going to be -6 plus 8. So it's +2. And lastly, we have -6 plus 2 times 5. That's -6 plus 10. So that's a +4. Now you have enough points now to produce or create the graph. So let's go ahead and do that. And I'm going to do this on a separate piece of paper. Just keep an eye on your points, okay? Keep an eye on your points. So the points that we're going to be using for the closed case, remember, I'm just going to write down the points here. We have 2, -5, and then we have 1, -4, and then we have 0, -3, and then -1, -2. And then for the open, this is the first expression, second expression. We've got 2, -2. And then here we have 3, 0. And then 4, 2. And then 5, 4. And so let's go ahead and create the graph. Okay. So I'll do it here on the side. So you can, because I wanted to have enough room here for us to see it. So let's do, I'll do the first one, this case here. So 2, -5. So 2, -5. So 2 on the x-axis, 2, and then -5, 1, 2, 3, 4, 5. And remember that this is going to be a closed circle, because I'm doing the case where x can be, so you remember this is x less than or equal to 2, and this one is x greater than 2, okay? So you remember. Okay, and so we've got the first point there, this one. So we got that one taken care of. Then 1, -4. So here's 1 and then -4. 1, 2, 3, 4. That's another point, right? Then 0, -3. 1, 2, 3, right there. And then -1, -2. So you see how, and remember you're coming from, so it's coming from, remember we read the graphs from left to right, so it's like a line that is falling, right? Coming from left to right, a line that is falling. So it's falling, right? But it stops right here. Now this is an open, this is a closed circle. So you do have a closed circle here. So I'm going to close it. That's a closed circle there. Okay. Now let's do the other, and I'll use a different color for that one. Let me use red for the second one. So 2, -2. So here's, we have 2 and then -2. Remember, that's going to be open. Okay. And then 3, 0. So a point right there, 3, 0. 4, 2. Point right there. And then 5, 4. Okay, and remember this is a line that is increasing because remember you do this from left to right. So you can put the arrow going that way. And so this is key right here to see that at 2, you have an open circle for the second case, and you have a closed circle for the first case. So now you find the graph that is closest to this. So let's go back to the final exam review document. And notice how the only one that looks like what we have here is going to be A. And, I know the arrows are pointing here, but, you know that this cannot be going towards the left, right? But it's important that you see how the way we read this is from left to right. So this is a line that is decreasing, and then we have a line that is increasing. It's just the art is a little bit misleading, the art here, because we don't, but A is the right answer, okay? So we have, and the way to know that the line is falling, this arrow pointing toward the left is misleading. It should not be, it's just a line coming down. And the way to know that is because when you look at the expression -3 minus x, look at the slope is negative. Right next to the x is a -1. So it's a line that is falling. So as x gets larger, the y values are dropping, right? So that is really what, but I just wanted to mention that because you see that arrow there pointing toward the left. And so that's an incorrect art that they're using here, but the graph is the correct graph. So the answer is A for number 4. Okay. So hopefully that makes sense. Now we're going to move on to question number 5. And we start working with, let's see, some examples of some applications of linear models. And these are really fun questions, I find, because that's really my field. So I really enjoy teaching these types of topics. Okay, so let's go ahead and read number 5. It says, assume that the situation can be expressed as a linear cost function. So that right there tells us a lot. It's a linear cost function. So we know that the form of the function is as a linear equation. So it's just like y equals mx plus b, but the application is for cost here. So it's a linear cost function. So we're looking for the cost function. What information do we have? So we know the fixed cost. So let's write that down. We have the fixed cost. Okay. And then what else do we know? We have fixed cost 100. So let's write that down. $100 is the fixed cost. And then we have also, we know that 40 items are gonna cost, they cost $1,700 to produce. And now we have to find the cost function. So let's do that. Let me stop sharing here so I can show you what I'm writing. Now remember, the cost function is linear. So a linear cost function has the form C of x equals mx plus b, where the this m is the variable cost per unit, and b is the fixed cost, total fixed cost, and x is the number of items produced. And C is the total cost. C is the total cost. Okay, so M is the variable cost per unit. That's M. Fixed cost is B. Number of items produced is X, and the total cost is C. Okay, so now that you know all that, and you already know that from your class, we're going to look at what we have. So we're looking for C of X. I'm going to use a different color here. So we're looking for C of X equals mx plus b. And what we know is that the fixed cost is 100, so we can replace b with 100. We know 40 items cost us 1,700, so I have the total cost, which is 1,700, for how many items for 40, so x is 40. So what's missing is the m, right? So I'm missing m, but we can find m because we have everything else. And so we can subtract 100 from both sides. And that's going to give us 1,600 on the left side. And then we have 40m. I can write it as 40m. And so we know that 100 cancels with the negative 100, and we can divide by 40, right? And so m gives us, so 1,600 divided by 40, the zeros cancel. So we have 160 divided by 40, that would be equal to 40, right? So 40 is equal to m. This was the missing value. Let me raise the paper up so you can see that. That was missing, right? The m. We didn't know the variable cost per item. We were missing this information. Now we have variable cost per item. And so now we can write our equation as C of x equals 40x, right, for the m, and then plus the fixed cost, which we already knew. So this is the equation. Normally, you just need to enter this 40x plus 100. Normally, the C of x will be already there as one of the choices there when you, depending on whether you're taking this on paper or online. But the linear cost function is 40x plus 100. And we use C as, to represent cost normally, but we can use anything else, but it just makes sense to use C for cost. Okay, so that's the answer to number 5, 40x plus 100, number 5. All right, let's move on to number 6. Number 6, it reads, the cost function is given below. Find the average cost per item when the required number of items are produced. Okay, so what is average cost per item? first of all, right? So let me go ahead and write the cost function. The linear cost function is given as 10x plus 1500, and it's for 1000 items. So we have the x value given, and we're looking for the average cost per item. So average cost per item for number 6, we're doing number 6. So, okay, by definition, average cost per item is defined as total cost divided by the number of items produced. Okay, so what is the total cost? Well, we have to figure it out. We first have to figure it out. So the total cost is 10x, so 10 times, we're talking about 1000 items, right? So you plug in 1000 items plus 1500. So now that in the numerator, I have the total cost. And then I'm going to divide that by the number of items produced, which is 1000. And that's going to give me the average cost per item, right? So you plug in the 1000 into the linear cost function, and then you divide that by the number of items produced. That will give you the average cost per item. And so we can do this with our calculator here, or if you prefer to do that on your head, but I recommend that you do just use your calculator. So 10 times 1000, and then plus 1500, and I'm going to divide that by 1000. And so that gives us 11.5. So that's the average cost per item, $11.50, average cost per item, okay? And the way that the notation that they normally use, in case you see that on one of the answer choices, for total cost, they use C of X normally, and for average cost, they will use C of X with a line on top, okay, to represent average cost. Okay, let's go to number 7. And it reads, the total cost in dollars of producing X college textbooks is given by the linear cost function 41X plus 62,000. What are the fixed costs? What is the marginal cost per book? What's the total cost of producing 800 books, 37,000 books? What's the average cost when 800 books are produced, and then when 37,000 books are produced? Okay, so let's go through the question. And for example, for part C and D, I will do the 800 case, and then I'll let you guys do the 37,000 because it's just the same process, okay? And so let's go through it just for the sake of saving some time here. All right, let me get a plain piece of paper here because we can't make these videos too long, we were told. So trying to be as efficient as I possibly can be without, of course, omitting important information. So 41x plus 62,000. So first thing, part A, fixed cost. Okay, so we have to find fixed cost. And remember, fixed cost, let me stop sharing. The fixed cost is just the B, right? So think of this as MX plus B. So fixed cost is 62,000. Okay, now that's the fixed cost. Second part, it's asking for the marginal cost. Let me just write down so I don't go back and forth. Let me write down marginal cost. And then for C, total cost of producing, I'm just going to do the 800 case. So 800 books. And then for D, find the average cost when 800 books are produced. Okay. Of producing. And I will let you guys do the 37,000 because it's just like C and D. It's the same, just like the 800 case. All right. So let's go ahead and answer these questions. So what's the marginal cost? Remember what, okay, by definition, marginal cost, this is the cost of producing one more book. In other words, the next book. And then furthermore, these are important facts. For a linear cost function, and you know what that means, right? C of x equals mx plus b. For a linear cost function, the average cost per item and the marginal cost per item are the same, are equal. So this is important fact. This is an important fact. So I'm sharing, I wrote it down there because this can save you a lot of time when you're taking the test to remember that for a linear cost function, right? Remember that that is C of x is equal to mx plus b. The average cost per item is the same as the marginal cost per item. Same thing. So if you know the average cost per item, and you know that because that's the M, remember we talked about that. So the marginal cost is the same as the average cost, so then this is going to be also $41, right? So it takes $41 to make to produce one more book, to produce the next book. So if they're currently producing 1,000 textbooks, or let's say 800 textbooks, the cost of producing the next textbook, the 800 and the way you say it, I guess, is 801st book, the next one, is going to be $41. So to produce that additional book, you can think of it as the additional textbook or additional book. How much would it cost to produce that? That's the marginal cost. And for a linear cost function, it's the same as the average cost per item. Now, to find the total cost of producing 800 textbooks, then you take the total cost function, which is this right here. So, and you're going to plug in. So for C, you're just going to plug in the 800 into the cost function. And so you have 800. So you write 41 times 800, right? And then plus 62,000. And what is that going to give us? Let's see. We have 41 times 800 plus 62,000. And that gives us 94,800. So the total cost of producing 800 textbooks is 94,800. What's the average cost of producing, I forgot to write here, 800 textbooks. So now what is the average cost? Remember, the average cost is the total cost. So I'm going to write average cost of 800. So remember the line, that means average cost. Average cost for 800. So let me go ahead and show you everything there. Average cost, this thing is getting in the way. Let me close this thing. Hold on. That's much better. Okay, so you got the note there, right? Let me display it again in case you didn't get that. So there's the note I gave you about marginal cost and average cost per item. And then we go to the question here. So now, average cost per item is going to be the total cost, which we found, 94,800, and then divided by the number of textbooks, so that's 800. And so when you calculate that, let's see what we get. So 94,800, and then divided by 800, that gives us 118 and 50 cents, so $118.50. So the average cost of, per item is 118.5, so pretty expensive, okay? So that's the average cost per item if we produce 800 textbooks, all right? And similarly, you can do the other two cases of the 37,000 textbooks. Just follow the same process as C and D. You plug it into the linear cost function and then divide it by 37,000. And then you get the answers. All right. So that's number 7. Okay, moving on. Let's move on to the next question. Number 8. Number 8, it says, this is going to be a little bit long because it has a lot of steps, and we actually have to come up with the function ourselves from the beginning. Like, we have to calculate everything. And I believe this is the one that has more steps, but we got to go through it. So let's read it. It says the manager of a restaurant found that the cost to produce 300 cups of coffee is $30.11. Okay, so the number of cups per coffee and then the cost to produce. So you can think of the, in terms of X and Y, X would be the number of cups and Y is the cost. So you would plot a point on the coordinate plane. And the reason why I'm bringing that up is because we're going to have to find the equation. And because it's a linear equation, we need 2 points. And then we find the slope. After we find the slope, we find the y-intercept. We have to find the y-intercept, which in this case will be the fixed cost to, and so on. So let's start because this is a little bit, it's not hard, it's just, it has a lot of steps. So let's see. So we have 300 cups of coffee cost us $30.11, while the cost to produce 400 cups is $39.71. So you can start writing the points already. Let's do that as I'm writing the problem here. So number 8. So X is the number of cups. I'm just gonna define them. So you know what we have. Number of cups. Let me lower the paper there. And Y is the cost. The cost to produce that number of cups of coffee, right? And so now, what do we have? We have the 2 points. So we have, first point is 300 for my first X. So I'm gonna label it as X1 because I'm gonna find the slope, and the cost to produce 300 cups of coffee is $30.11. That's my Y1. And then we have 400 cups of coffee, so 400 comma, and that's going to cost us $39.71. And so we've got X1, Y1. Oops, X1 and then Y1. Sorry about that. All right. Now, all right. So, yeah, we have to start looking at, first part is part A. It says find a formula for the cost. Well, we have to start looking for the equation. And if you remember how to find a linear equation, so what I did is, okay, remember, X is the number of cups of coffee produced, Y is the cost of producing that number of cups of coffee. So we have a first point is 300 cups of coffee, cost $30.11. And then we have, this is X2, Y2, sorry about this right here. So 400 cups of coffee cost us $39.71 to produce. So let's find the slope, and what we're doing here is finding the average cost, right? The M, remember? So remember how to find the slope of a line. And why do we use the same formula? Because remember that this is a linear cost function, and so it has the form, if you graph it, it's actually a line, right? So that's why we follow this process. And so remember, for the slope, we find y2 minus y1, and then x2 minus x1. Now, M for us in this problem represents average cost per cup of coffee or marginal cost, right, for us. So, okay, so y2, that's going to be 39.71 minus y1, so minus $30.11, and then x2 is 400 minus x1 minus 300. So you use your calculator. So we've got 39.71 minus 30.11, and so we get 9 point, and we're going to round this, so 39.7, let me try it again. 39.71 minus 30.11. My calculator is not rounding the way, well, 9.6 is what I'm getting, right? And then when you divide by 100, that's going to, remember, move the decimal point 2 places to the left, so you get 0.096, right? That is what you get. Now, I noticed that there was an error in the answers on this one. When I was looking at the questions, I selected the questions and I worked out the problems myself just to make sure that everything was good and that you guys were getting the right questions to prepare for the final exam. So, of course, we got to go in and do it ourselves and everything. And I noticed there was a typo there. So if you see a typo in the answer choices, just know that they just made a little error there when they gave you the answers. But anyway, so we've got 0.096 for the M. Now, next step is to start working on creating, remember, we're looking at part A, setting up the linear cost function. So C of X equals MX plus B. And so we have now the M, which is 0.096. And so now you can use an X and a Y. Remember that the Y is the cost. So C is actually the Y, right? So you can use any of the points. So I'm going to use the first point to find the B. So use one of your points. You can use the second or the first. I'm going to choose the first point. The X 300, right? For 300 cups have a cost of $30.11, right? And so now I'm just going to look for B. Because remember, B is missing the fixed cost. So 0.096, you multiply it times 300. That's going to give you 28.8 and then 30.11 plus B. And then you subtract 28.8 from both sides in order to find B. So 30.11 minus 28.8, which gives us 1.31 equals B. Now that's the fixed cost. So you can now write for part A, the answer would be C of X is equal to, and then we have 0.096x plus 1.31. So this is the linear cost function, right? So we have the linear cost function. Now what follows after that? Let's take a look. For A, we found the A part. Now what's the fixed cost? We can answer these questions now. So for B, the fixed cost is 1.31, right? For B, 1.31. Now find the total cost for C. Find the total cost of producing 1,100 cups. So you just plug it in, 1,100 cups. Let's do that. So the fixed cost, I wrote it here, B, fixed cost is $1.31. And then the total cost of producing for C, we're going to find the total cost of producing 1,000. So you're going to plug in C of 1,100 items, right? And so you plug it into your equation, 0.096 times 1,100 items plus 1.31. And so you figure that out with the calculator, 0.096 times 1,100 plus 1.31. That gives you $106.91 for the total cost of producing 1,100 items, right? All right, now, and that's part C. Now, what is part D? 1,100. I did 1,100. Now, find the total cost of producing 1,101. You know, let's do that because we want to show there's something that we need to show here about marginal cost. That notice how from part C to part D, we go from 1,100 to 1,101. So if you find the total cost of producing 1,101, and you already have the cost of producing 1,100, when you subtract the two, you get the cost of the next unit, right? From 1,100 to 1,101. So really what you're getting is marginal cost. So it's a good exercise to go ahead and do that and compare the answers to see that indeed marginal cost is the cost of the additional item produced. So let's do that. Let's go ahead and work number D also, I mean part D. So part D, you plug that in, you know, part D. Right. Remember, part C is just the cost. I'm just going to write it here so we have both of them. The cost of producing 1,100 units, we found it to be 1,100, we found it to be $106.91, right? Yeah. Now we're going to find the cost of producing 1,101. Let me stop sharing here so you can see. So now the cost of producing 1,101, we plug it in, right? And let's take a look here at the equation I had. So you go ahead and plug it in. It's 0.096 1101, and then plus 1.31. See what that gives us. So it's 0.096 times 1101 plus 1.31. And so we get 107.006. 107.006, right? And if we round this one, it's 107.01 rounded, right? If we round it to the nearest cent. Okay, now, if we go to part E is asking for the marginal cost. So this is going to be interesting. It says marginal cost, and it says of the 1,100 at first. So of the 1,100 and first, okay, 1,000, sorry about that. A little confusing there. For E is 11101. So it's 1101. So the 1,101st. It just sounds very strange. A cup, right? So we want to find that. Now, we can do it just by looking at the marginal cost that we already computed, really, because marginal cost doesn't change once we know it. So E, look, let me show you something. We don't have to calculate it again, but I want to do it so that you can see that indeed is the cost to produce the next item or the next cup of coffee in this case, right? So the cost function, remember, the linear cost function is C of x equals 0.09x plus 1, this is 6 here, 1.31, right? So 0.096x plus 1.31. Now the marginal cost just from the equation is 0.096, right? We already know that. So the marginal cost of producing the 1,101st cup is going to be this. We don't have to do the calculation. However, let's do it so that you see that indeed that's the case. So marginal cost is gonna, of the 1,101st cup, you can take the cost of the 1,100 cup, right? And then the 1,101, and then subtract the two. So you take the one of 1,101, because that's the highest one, so 107.006 before rounding. And then you subtract it from the cost of producing 1,100 cups. So that's going to be 106.91, right? So this is 1,100 cups, 1,101 cups, sorry. And then this one is 1,100 cups. And when you subtract the two, notice that you're going to get exactly the marginal cost. So the cost of the additional cup of coffee, basically. So 107.006 minus 106.91 gives me exactly the 0.096, which proves that this is indeed the right amount. And, there was a typo in the answers there. So, okay. So you see how, okay, so when you look at the total cost of producing 1,100 cups, and then the total cost of producing 1,101 cups, and then the cost of producing 1,100 cups, and you take the difference of the two, you're going to get the marginal cost as well, like that. But we didn't have to do that because we already knew that it was 0.096, because we know from definition that in a linear cost function, the average cost and the marginal cost are the same, right? But this really just shows you so that you remember that fact, okay? This one. So that's part E. And then let me see if there's any more. There's additional part there. Let me make sure that you see everything here. I'll move the paper around. Okay. Okay, now let's go to the next part. See if there's another part here. F, what's the marginal cost of any cup and what does it mean to the manager? Well, the marginal cost of any cup, and then you have some choices here. What does the marginal cost? We know the marginal cost, you already know, is 0.096, right? So that's about close to 10 cents. So you know the answer already. So you can enter it there. So for F, you're going to enter 0.096, right? And then for the, what does it mean to the manager? Then go through the choices and see which one makes more sense. It says the marginal cost of a cup of coffee is the cost of producing a given number of cups. No. The marginal cost of a cup of coffee is the cost of producing the first cup. No. The marginal cost of a cup of coffee is the cost of producing one additional cup. Yes, that's the right answer. So C is the right answer. C. Okay. Okay, so let's move on to question 9. And remember, the first set of this review only has questions 1 through 10. So after question 10, we'll stop, and then the second set will include questions 11 through 20, and so on until we get to question 50. So you'll get 5 sets. So this is pretty long, and the whole thing is going to be really long. But remember, we're covering an entire course, so you expect it to be long, right? Okay, so 9, let's take a look at 9. It reads, the revenue in millions of dollars from the sale of X units at a home supply outlet is given by, so you got the revenue function. Remember how you get that? Price per item times items sold. That's the revenue, right? So if you are a supplier, you price your item and then you sell a number of items. So the price times the number of items you sell, that's your revenue, right? X represents both items sold and produced, depending on whether you're the supplier, right? Or if you're going to be the what do you call it? The consumer, the supplier. It depends on where you are. So, okay, so now the profit of, and then we know the profit in millions of dollars from the sale of X units is given by, okay, so you have the revenue function and we have the profit function. Then you have to find the cost function, and then the cost of producing 5 units and the break-even point, break-even. So we've got a lot to do here. All right, let's take a look at what we know. First thing is, what do we know? We have revenue function. It's 0.26x. We have the profit function, which is 0.081x minus 0.7. And we need to find the cost function. So find cost function. And so first step. So the cost function, is C of X equals MX plus B, right? By definition. The revenue and then the profit function by definition is the revenue function minus the cost function. Okay, so this is by definition. And so what do I know? I know I have to find the cost, but I have profit and I have also revenue. So I'm going to use those two. So I have profit and I have revenue. So let's use that. And let's use this equation here. So the profit I know, and that's going to be 0.081x minus 0.7, right? I know my profit function. It's going to be 0.081x minus 0.7. I know my revenue function also, so it's going to be 0.26x. And then I don't know my cost function. That's what I'm looking for. So I have minus, I'm following the formula here, C of X. Okay. Now, okay, so it looks like I have to find C of X because that's what I'm looking for. So it wouldn't be a hard. What I can do is move everything to the left and just leave the C of X alone because that's what I'm looking for. So I'm going to move negative 0.26x to the left by subtracting it. Negative 0.26x, subtracting it from both sides. And that's going to give me on the left side, well, let's see, 0.081 minus 0.26. That gives me a negative 0.179x, right? And then bring down the negative 0.7. And then the 0.26x cancels with the negative 0.26x. Those disappear. But I still have negative here, C of X. Okay. Well, because I have a negative here, I need to get rid of this negative. So I can just divide that by -1, but I have to do the same thing to the left side. And notice what's going to happen to the signs of the expressions on the left side. The negative 0.179 is going to change to a positive 0.179x. And the negative 0.7 is going to change to a positive 0.7. And the negative c of x will change to a c of x. That's exactly what I wanted. And so you have now the equation you were looking, we needed to find is the cost, the linear cost function is 0.179x plus 0.7. That's the linear cost function. So that's part A. So that was the first step, finding this linear cost function, part A. Now part B is we're going to use this linear cost function and we're going to find, so we found A. Now B is what's the cost of producing 5 units? So we just plug it in. Cost of producing 5 units. We're going to plug it in here, right? We can do that, you know. So for B, just plug in 5. And that's going to give us 0.179 times 5 plus 0.7. And so let's see what we get here. Times 5 plus 0.7. And we get 1.595 for the cost of producing 5 items here. Okay, that's part B. And part C, it's asking for the break-even point. So remember the break-even point is where revenue equals cost. Now you have cost. So now that you have your cost function, to find the break-even point for the last part, which is C, right? Let me go there. So to find the break-even point for part C, break-even point. So the break-even point happens where revenue equals cost. And so we know we have a revenue equation, which is given as 0.26x, right? And then we find our cost. We just found our cost equation to be 0.179x plus 0.7. Now you want to find break-even point. That's where, and that would be in x. How many units do we have to produce to break even, right? And so we're going to find x. So you can move this 0.17x to the left by subtracting it. You want to keep the x positive, so you subtract this one. And that's going to give us, well, let's see, 0.26 minus 0.179 gives us 0.081x. And the 0.179x cancels with the negative 0.179, and then we bring down the 0.7 and then divide by 0.081. And so that's going to give us x equals, whatever we get there, 0.7 divided by 0.081. And we get 8.64 something, so we can 8.6. We can probably round up to 9 units because we can't really produce 8.6 whatever, right? So I would say rounding up to 9. I don't know what the answer is given there, but even if it gives you like an 8.6 something, you got to use common sense. You can't produce 8.6 items. So because it's 6 here, so if it were 5, anytime you have a 5 or more, anytime, well, in this case, you want to break even. So anything below that, it's not going to give you the break even point. But when you enter the answer, I believe the answer has to be given precisely. So I'm rounding 3, I'm just keeping 3 places here. I know we get this really. It's 8.6419, all that. But I'm rounding here because I think that it said round. Let's go ahead and look at the question here. I think it asked us to round to the 1,000. Okay, so we round to the 1,000. Now in the real world, it wouldn't make sense to make 8.64 something, right? But it's asking for us to round to the 1,000, so we just need to round to the 1,000 unit, and that would be 8.642. Okay, 8.642. All right. Moving on to the last question. The last question for this set of problems is going to be question 10. It says, suppose you are the manager of a firm. The accounting department has provided cost estimates and the sales department sales estimates on a new product. Analyze the data they give you and shown below. Determine what it will take to break even and decide whether to go ahead with the production of a new product. Well, we have to consider whether or not we want to move forward with this new product. So we have a cost function. Let's write that down. So the cost is given as 120x plus 25,280. And the revenue is given as 160x. No more than 1,341 units can be sold. So you need to remember that fact. So no more than 1,341 units can be sold. So we are restricted by how many units we can sell. We have to find the break-even quantity and then answer those questions. So let's find the break-even quantity. And remember how we do that. We have to set break-even point is when the revenue equals the cost. And so the revenue is 120x plus 25,280 equals 160x. And so now we're going to subtract, keep the x positive. So I'm going to subtract 120x from both sides. Because, it makes sense to keep the x positive, talking about units sold or produced. In this case, sold. So the 120x is going to cancel. You bring down 25,280 equals 160x minus 120x is 40x. And then you divide by 40. And that cancels 40 here on the right side. And we have x equals. So 25,280. Now divided by 40. You get 632 units to break even. And so let's go ahead and go to the questions there, to the question and read what we need to fill in there in the lines. So the break-even quantity is 632, which is less, right? It's less than the number of units that can be sold, right? Because we can sell up to 1,341. So that's less than the number of units that can be sold. So then the firm should produce the product because it would make money, right? Remember, it takes 632 units to break even. So, and I can produce up to 1,341. So it makes sense to expand in this case, right? This makes sense. All right. So the answer then would be in terms of 1, 2, or 3. So the break-even quantity is 632, which is less than the number of units that can be sold. So it's less, right? So here less. And it would make more money. Yes, it would make more money. So that's what you should answer. So the break-even quantity is 632, which is less than the number of units that can be sold. And that is, so the firm should produce the product because it would make money. Okay? It would make money. So it's definitely should. So it's kind of confusing here how they have the words, but let's see, for number 1, you want to do less, right? Number 1. For number 2, you want to say should produce. And for number 3, it would make money. It would be the make. So I see it now. Okay. All right. Well, thank you for being patient through this first set of questions. And so I will go ahead and work on the second set. I hope this was useful. All right. See you on the next one.